Hello, everyone, and welcome to today's live learning event, part two, using Grooper and Azure Document Intelligence. Last month, we began learning about using Azure Document Intelligence, and specifically, that was about OCR with the new Azure DI OCR engine. Today, we'll focus on the DI analyze activity and how it's used by AI-enabled features like AI Extract. Thanks for joining us. My name is Brad Blood, and I will be the moderator for today's event. If you have any questions, you can send them in through our Q&A box at the bottom of the screen, and we will answer your questions as time allows. We're also recording this meeting, and we will be sending out a link to everyone who registered for today's event. We will also add the video of this to the Grooper YouTube channel, so be sure to subscribe to Grooper AI on YouTube to never miss any of these videos or a lot of other stuff that we'll put up. All right, today's speaker is Dylan Greenwood, Director of Product Operations here at Grooper. Dylan is dedicated to educating Grooper users on the possibilities of intelligent document capture. And with a background as an educator, Dylan's aim is to increase understanding of the Grooper platform, leading to effective and efficient document processing solutions. Dylan's work includes designing Grooper University coursework and robust documentation on the Grooper Wiki. Dylan, take it away.
Thanks, Brad. So welcome everybody. We're going to be continuing our discussion about our fairly new integration in Grooper with Azure Document Intelligence. And like Brad said, last month, if you were with us, we focused mostly on how we can use Azure Document Intelligence purely for OCR. And there's good reasons to do that. Kind of to sum up what we talked about last month, number one, it is going to be the long-term support way to access Azure's read engine. So if you're currently using Grooper's Azure OCR engine, that utilizes the 3.2 version of that engine, whereas Document Intelligence utilizes the 4.0 version of that engine and will be supported longer term than the older read models. So that's good enough reason, just because the read engine gives you great OCR results, right? And there's some other benefits in terms of Document Intelligence ability to capture checkbox locations very accurately and barcode data very accurately, which makes it just a good OCR engine in and of itself. But there is some additional stuff going on with Document Intelligence. There's a lot more that this service does in terms of analyzing the document structure that is not capable of being extended with by an OCR engine alone. And that is why we have a brand new activity called DI Analyze. DI Analyze takes that additional analysis data, that additional intelligence that Document Intelligence provides, and saves it to documents in Grooper that can then be utilized by features like AI Extract. And I'm actually going to go outside of Grooper a little bit to show you the types of things that Azure Document Intelligence is doing. So this is the Document Intelligence Studio in Azure. I'm going here just because, well, it quite frankly does a really good job of showing you what it's doing behind the scenes. And that'll hopefully let you understand a little bit better what Grooper is utilizing in terms of AI. So this is our first document that we're going to focus on. This is just kind of a dummy document that's a really basic form. And I'm going to run analysis on this document to show you the types of stuff that's being analyzed and collected here beyond just regular old text data. So as you can see, what Document Intelligence is doing is it's detecting certain parts of the document, like, oh, it understands that this is a title. This is a polygon of some kind with text in it. It even does stuff like identify structures that look like tables, right? And it formats it in such a way that is really, really easy for an AI to understand. And, even selection marks, we talked about that last week. Here's how it understands where those checkboxes are, right? So you get a lot more than just, hey, here's where the text is, here's where the characters are, and, maybe here's where some layout data is. You get a lot of information that's passed in terms of how this forms a document structure. Now, as far as how you get Grooper to access that, that's what this DI analyze activity is all about. So I'm going to start with just a simple example of how this would operate within Grooper in sort of like a normal batch process flow. So here I've got just a real basic model built out for that form we just saw. And the process would look, something more or less like this. Let me get to the right batch here. First you're going to split out your pages, kind of like normal stuff in Grooper to get those page objects. Then we've got the DI analyze activity itself. And the first thing that I'm going to point out is this activity can run on the page or the folder level. It defaults to page, and there's good reason for that. I will actually get into the benefits of running this on the page versus folder level later on in this session, once we kind of get an understanding of what this is actually doing. But, the big takeaway, if you're new to DI Analyze and even if you're unsure about like, hey, should I run this on the page or the folder level, stick with the page level. That's definitely the best jumping off point for the scope to apply this activity. We're going to use the pre-built layout model. As we talked about last time, Azure Document Intelligence gives you access to a lot of built-in models. And some of these models are, kind of fine-tuned towards different types of use cases. At least currently in our implementation of this feature, we've really focused on two primarily. Pre-built layout is the kind of generic purpose document analysis engine or model. And then pre-built read is basically just used for OCR. So I'm going to stick with pre-built layout. And the content format here I'm choosing is Markdown. You've got two options here for a content format. You've got either text or Markdown. One of the things that I want to mention right off the bat is the whole reason for this activity, DI Analyze, is collecting data that can be utilized by an LLM in something like AI extract. And LLMs really do well understanding a document's content when it's presented in a markdown structure. Markdown, if you're not familiar with that, what that is, that's just it's a hypertext language that is basically a little bit more than just flat text. It allows you to format stuff, define section and title headings, define stuff like table structures, stuff that's really, really important for extracting data from a document. And this will probably make a little bit more sense if I show you some of the diagnostics for this activity in the tester. So I'm going to go ahead and run it on this page. It'll take a little bit to process. And once this is done, we're going to look at the diagnostics that Grooper generates for this to really show you what's happening behind the scenes here. So in terms of what we get back from Azure, we get a really pretty big JSON file. And this has a lot of information that we're going to use down the road to ultimately build the best version of this document that we can and send it to an AI. So it's got location information of those different kind of elements that we saw here in terms of what we're seeing visually here. All that is represented in this JSON. And it's pretty big. I mean, this is an 8-page JSON file just for that single page, right? That allows us to do stuff like convert this image of a document into a markdown file, which is what you're seeing here, this markdown version of this page. And I'm going to flip over to the code view here and show you something that is really powerful, or one of the things that makes this really, really powerful. So you see this table structure that Document Intelligence identified. It's a small table structure, but it's still a table structure. And AI will really understand this structure. Table extraction is always challenging in one way, shape, or form, partially because of just the complexity of how these columns and cells and rows can be structured. But when you break it down into something like HTML, there's your table header, there's your table header, there's a row, right? It's really easy for an artificial intelligence to understand, what is actually happening in this table. So this alone makes this very, very, very powerful in terms of manipulating the text content and injecting some additional analysis. We also have an HTML formatted version of this text, and this will play a very, very important part later on in our discussion when we talk about how document intelligence and DI analyze work really well to solve some of the highlighting problems we've seen in the past when using LLMs to extract data using AI extract. Any questions before we continue, though?
Nope, none so far. You're doing great.
Perfect. So that's really all about this single activity and kind of the files that it produces and the analysis that it's producing. Okay. So then your first question, or at least my first question when I learned about this DI analyze activity was, okay, that's great. It's producing this additional analysis file that's going to get used for AI extracts, but, I still want to get OCR data. How do I do that? And the simple answer is just add a recognize step. So here I've got a recognize step coming after DI analyze, and it's pointing to an OCR profile that is configured to use Azure DI OCR. It's important that I'm using the same model here, and it's important that all of these features are configured the same way as well. Essentially, this configuration for document intelligence in the OCR profile is the same configuration for document intelligence in DI analyze. The reason why that's important is if you do things in this order, DI analyze first, then recognize, you're not going to submit the page for analysis twice. This service costs money, right? When you're talking about submitting these pages to the document intelligence service, you get charged a little bit. If you're using the layout model, it's about a penny a page. Well, you certainly don't want that to be 2 pennies a page to get basically the same data, right? As long as that data file is already present from DI analyze, it's just going to use that already present data file to generate the full text. So I'm going to go ahead and run it. And it does take a little bit to run because not only are we kind of analyzing that already present data file, but we're also doing the things that Grooper normally does with Azure DI OCR. We're running that secondary OCR pass behind the scenes to kind of clean up and massage the results a little bit where we know traditional OCR engines do a little bit better job. But you'll very, very clearly see in the kind of execution logs here, we didn't actually make a call to that service ever as we would have if we did not run DI analyze first. Any questions about that?
No questions so far, but just a reminder, you can send those in on our Q&A or chat box at the bottom, and we will get to those pretty quickly.
Perfect. So long story short there, just make sure you do this order of operations. DI analyze, then recognize. Now, as far as the extraction here goes, I'm going to flip to my data model tester. So again, I can show you a little bit more behind the scenes what's happening here. And I'm just going to let that run. So you'll see I'm getting pretty good results here. These are very accurate results. Even these checkbox values are very accurate. They're not being highlighted for a good reason that I will get into a little bit in just a second. Even this signature field, it was able to see that there was a signature detected. So all of this is very, very accurate. How did I get this to work? That's what you should be asking yourself. Very, very, very key part of the fill method configuration here. I don't want to use the just full text of the document, right? I want to get that additional benefit of using that DI analyze data. That is why in my AI extract configuration here, I'm using a different document quoting method. We have a brand new quote format as far as our options here go. Oops, didn't mean to click that. Sorry, guys. Called DI layout. So going from kind of the defaults here, your process will be, pick your model for your generator settings, and then in your document quoting, make sure and choose DI layout. And getting started configuring this DI layout, you've got a few options for the quote format. This is the only required property you need to configure. You've got a choice of Markdown, JSON, or HTML. Markdown is basically going to use that Markdown formatted file we saw in the diagnostics. Again, AIs, LLMs work really, really well when they're handed Markdown. It's a format they can work with very well and give you accurate results. I will say, just as a matter of our own internal testing, very, very early on, once we first implemented DI analyze and DI layout, just providing the quote format as Markdown instead of full text, we actually saw a pretty significant increase in our no-touch rate in a process that deals with EOB processing. EOBs are notoriously complex in a lot of ways. Their structures change from provider to provider. It's almost like they kind of make these things hard to read on purpose, quite frankly. And we saw about a 10 to 15% no touch rate increase just using this markdown quote format. So really, really good results without a whole lot of configuration other than supply the LLM with a different version, a better version in terms of the intelligence around understanding its structure
Hey,
using
Dylan,
Markdown. Oh, yeah. What's up,
we
Brad?
did get a quick question. What does the DI analyze file look like?
What does it look like? That's a good question. Let's just show you exactly what it looks like. What happens after DI analyze runs is this file right here gets built and saved to the object. And it is a JSON file, and you can see all of the different stuff that we're getting back from the document intelligence servers here. This content is basically the text content of the document. You can tell probably just seeing that we've got some of those table HTML tags that this is formatted in Markdown. And then it's got some additional information as well. This pages collection has a bunch of information about the physical locations of these segments and stuff. If we have checkbox data, that's also going to be here at some point in this big old file. Barcode data, somewhere in this big old file, stuff like that. Okay, that was a great, great question. Thank you for letting me show that. Let's get back to configuration here and talk about some of these other options. Actually, perfect. I'm very, very glad you had me show that. If you choose this JSON option, rather than using that markdown formatted version of the document, it's actually going to use literally that JSON file I just sent you. So if you need not just the text content of the document reformatted in Markdown, but perhaps some of that other additional information that's buried in that JSON structure, this would be why you use that. As a practical matter, though, your two best options, certainly in our testing so far, seem to be Markdown or the next one, HTML. And HTML solves a really big problem that has kind of plagued AI extract for a while. It helps us really solve that problem of alignment. So first, let me just show you what's going on behind the scenes when you choose that HTML option. And I know we're running kind of close on time here, so I'm going to probably go faster on a couple of things. In this diagnostic, you can see in the chat log that something different gets sent to the AI. We actually take that analysis from Azure Document Intelligence, all of that information about the boundaries of these text segments and locations, and use that to convert the text into an HTML format. And you can see, we've got a paragraph tag for this segment for the account authorization form. Very, very importantly, we've also got page number and boundary information. This is critical for getting better highlighting alignment, taking the result that an AI gives us in terms of here's the data, it's accurate, how do you know where it is, and aligning that back to the document. And that solves really, really common problems like we see in documents like this. So I didn't actually have to work super hard to find examples of poor alignment when you're not using document intelligence, or specifically when you're not using that HTML formatted version. Here we aren't getting any highlighting. Is that invoice date accurate? Yeah, it's right there. Why aren't we getting highlighting? Well, because the natural form of alignment is just trying to match literally these text characters against the document. And this format of the date is not this format of the date, right? So yeah, it's accurate, but we're not getting highlighting because that's not literally what's in the text of the document, right? This is also super, super common. This invoice total is accurate. That is the total due, but we're getting this subtotal highlighted. And this can be really, really confusing when you're extracting patterned data like this, numerical data on larger documents, and you need to be really, really clear on, hey, where did this value actually come from? I can guarantee you the AI got it from this text segment down here, but our alignment is such, well, hey, that's the first instance of that value on the page, right? And so you get this kind of disconnect of like, yeah, that's right, but it's really hard for a reviewer to verify that, right? Tables are very similar, have a very similar problem. Yes, that description is accurate, but we're not getting the highlighting we want because Grooper's kind of default way of doing things is, look, I'm just looking for a single line of text for this row. Falls outside of that single line of text, doesn't get highlighted. Long story short. With HTML alignment, or excuse me, that HTML format for DI layout, we have some additional information that we can use to better align the results to the document. So it's kind of a 1-2 punch here. I've got my quote format set to HTML, and I've got my alignment settings configured to use the geometric alignment. With those two things in place, we get much, much, much better highlighting here. Now that we've got the capability of saying, okay, well, where did you really get this from? And where's the actual boundaries of that value? We can better highlight these results very, very clearly, showing you exactly the portion of the document that was used to generate that response. Any questions about that before we move on?
No, none right now.
Okay, perfect. This is also really important with checkboxes. So one thing I want to point out really, really quickly is, we talked last time about document intelligence's capability of giving really accurate checkbox locations. We can see from the layout data here, gangbusters. We've got all of these boxes correctly identified. And in terms of Grooper's, traditional method of extracting, this is great. We can use something like labeled OMR to extract this data very, very accurately. And we do so right here, right? Great, fantastic, wonderful. But it's still a lot of work, right? You're still talking about configuring that extractor for every single one of these fields. The actual document I got this from had something like, I don't know, but definitely over 20, maybe close to 40 or 50 different fields. It's a lot of work, right? One of the benefits of using AI is supposed to be, you don't have to do all of this tedious configuration, right? Well, one of the benefits of document intelligence is you don't have to do all this tedious configuration. You can get very, very accurate results even from these checkbox fields without doing anything to the value extractor here. And that's what we see here, right? But in this instance, I'm just using that markdown format, so the highlighting isn't great. Yes, these values are accurate, but we're seeing that issue of, yeah, you're matching something on the document, but it's not really where it should be matching, right? 8B should highlight something down here. With that HTML aligned version of extraction, we get something that is a lot more practical. Here we're actually highlighting basically the entire polygon that was used to identify, hey, what is the actual checkbox value here? Yes, no, over $10,000. Now, it's not, just that text over $10,000, but in terms of a reviewer, yeah, you're spot on in terms of drawing your eyes towards what the LLM actually used to answer the question here. So big takeaway there is the HTML format gives you a lot better information in terms of, wrong one. HTML format with DI layout gives you a lot more information about the boundaries of these different portions of the document that can then be used to better align the responses that the LLM gives using this geometric field alignment. Okay, I know I only got a couple of minutes. There's one big thing I do want to show you guys, if nothing else, just to put it in your brains. But before we get to that, do we have any questions?
Yeah, we do. So the first one is, do the different quote formats submit longer or shorter information to the LLM so that the token consumption is different or the results take longer?
Yes, that is a great question, something I should have mentioned. Long story short here is, yeah. The kind of downside to using something like this HTML format is there's more text data. just by wrapping all of that text in HTML elements and including the boundaries in those HTML elements, yeah, you're gonna get more text data. So yes, there is going to be more tokens passed in the prompt by virtue of doing that. So, you kind of got a takeaway here. Do you just care about accurate extraction? If so, Markdown works great. You're going to save tokens. You're going to get very, very accurate results, but your highlighting may not be exactly what you want. But hey, if you never have a reviewer look at these documents, yeah, just use Markdown. That's great.
And
Benefit
then,
of the
oh, sorry, go
HTML
ahead.
is obviously, you get more information back. You send more information to the LLM. So we can use that for highlighting on the back end. But just to hammer that point in, more tokens, higher token cost, higher analysis cost in terms of time. Go ahead,
Great,
Brad. I'm sorry.
thanks. Yeah, no problem. And then the second one is, does DI analyze also create a layout date JSON file on the batch page node?
Does it create a layout data file like the Grooper layout data file? No, it does not. The only activity that creates that layout data file, well, I shouldn't say that, but using Azure DI, the only thing that creates that layout data file is recognize. So no, DI analyze doesn't create that kind of grouper file you guys are used to in terms of this bad boy right here. It creates this file right here, which has, it might have some of that information encoded in it, but in order to get it to this format that Grooper uses for extractors like labeled OMR, for example, that is why you would need to run recognize, as we see here with an Azure DIOCR profile. All right. Any questions about that?
You got us taken care of. Thank you.
Okay. The only thing I do want to mention, at least briefly, we might touch on this in a future webinar since we're, kind of running out of time here. There is a additional method of better aligning a LLM's response to a document called spatial grounding. So if this is really, really, really important for you, or you just have a document set that is very, very, very complex. Now, one of the downsides to doing things the way I've showed you so far is you're basically asking an LLM to do two things at once. One, answer a series of questions, right? Extract the data from these documents. And then two, figure out how to align it back to the document, right? And doing that all in one LLM call, you're basically doing two jobs at once, right? And it's always, whether you're talking about LLMs or basically anything else, you usually get better results when you have very directed tasks, right? So, if you can separate the process of an LLM finding those results, fill in the data model, and then separate the process of, okay, now that I know what these results are, how do I align them better up to the document? You can get much, much better results on both ends, both the accuracy of the extraction and the accuracy of the highlighting. That is what spatial grounding is all about. I know we're running out of time, so I'm not going to show you exactly how this works, but the general idea is this. You run two different fill methods in a data model. First, AI extract. You can still use DL layout, but if you're just concerned with the accuracy of the results, just use that markdown version. That's going to save you some tokens. And in terms of the alignment, don't even do it. Set all of these properties to none. That will also actually save you some token cost as well. Then we have a brand new fill method called spatial grounding, whose entire job is to use an L to align results back to the document. So here we would supply that HTML format for our quote, which has that additional information in terms of the boundaries of these text segments. And that is what would be used to say, okay, well, now I got data in front of me. Where should I look for this data on a document? And the kind of short takeaway here is by divorcing these two separate operations into two different fill methods, you get better results in terms of your accuracy on extract. You get better results in terms of your accuracy on the highlighting, but should be obvious, you get two calls to an LLM. So the token consumption is a little bit greater. All right, if we've got time in a future webinar, I will show that off in more depth, but I did just want to kind of put that bug in your ear right now, since it is related to document intelligence very specifically. All right, sorry to go over a little bit, guys, but I do want to leave time for questions if you have them. Brad, do we have any questions?
No, no, we don't right now. I think you've answered everybody's burning questions that they have. So yeah, thank you, Dylan. That was great.
Okay. Well, if you guys do have follow-up questions, feel free to reach out to me. I'll be happy to answer anything. Hopefully, we'll see this at a future webinar in more depth as well. So if you're still kind of a little bit unsure about how this works, I'll try and cover that next month and save some time for it.
Yep. Oh, wait, we did get one more question.
Okay,
Since the
let's go.
Azure calls seem to take time, does
Mhm.
Grooper multi-thread this to improve total processing time for a batch?
Yeah, great question. So if you are running it at the page level, yes. And this kind of loops back to what I was going to talk about. If you're running it on the page level, DI analyze, yeah, absolutely. That's going to take care or take advantage of Grooper's multi-threading, obviously one thread per page object rather than one thread per document object, right? And yeah, generally speaking, that's kind of the way you want to do it for exactly what you just described, right? You increase your processing time, or actually, I'm sorry, reduce your processing time by taking advantage of parallel processing. The only caveat that I will mention in terms of running this on the folder level is if your use case is really specific in such a way where you've got multi-page documents and they've got structures like tables or paragraphs that span multiple pages. So you've got table starting on page 1 and then it continues on to page 2. Sometimes it's better to run it on the folder level just because the analysis sort of understands, oh, okay, well, we've got this spanning multiple pages, but the structure is really one structure. So you don't kind of get a gap in between, say the table on page 1 and page 2. That's a fairly specific scenario, and it's kind of use case specific whether or not you seem to get a better benefit in terms of that particular problem running it on the folder level. But I did want to point that out. That is why we have this capable of running on the folder level, is to kind of account for those scenarios where you've got documents that have structures like tables or paragraphs that can span between multiple pages, and it's important to capture that as kind of one unit. Does that answer the question?
Yes, thank you. Thank you.
Okay. Excellent.
Awesome.
Anything else, guys?
I don't think so. Thanks, Dylan. Remember that we'll be emailing out a link to this video in the next couple of days, either Thursday or Friday. And then we will also add this to the Grooper YouTube channel. It's just Grooper AI if you search in YouTube. We encourage you all to rewatch this or share it with any coworkers who might benefit. And if you're ready to learn more about how Grooper can help you out directly, please don't hesitate to reach out to myself, Dylan, or anybody else on the Grooper team. But thanks, everybody, and have a great